So, friends, today, now from tomorrow onwards, we are heading for physics classes. But today, I am going to, God bless you, I am going to move on the second part of the circle. Yesterday, we had come to know about a circle and its chords, exterior point, interior point on the surface, diameter, everything we have studied. But today we are going to use all those properties. Now, a theorem is one theorem which is very much important as this is the for the very beginning. Yesterday when I made a live video, and that time I had given a description just below that video. You have to go for that description, because there I have mentioned the class 9th course for the CBSE and ICSE boards both, and they both are having the same course pattern. So you don't have to worry whether this is for the ICSE classes or for the ISC or CBSE classes. This is meant for both. Okay. So friends, now the line drawn through the center of the circle, I am going to make, what is this theorem? The line drawn, the line is drawn through the center of a circle, through the center of a circle, the center of circle, to bisect a chord, to bisect a chord is perpendicular to the chord, is perpendicular to the chord. Got it? Now, why I have written it here? A very important thing I am going to tell you: to solve any question, whether it is a question of mathematics, it's a question of physics, chemistry, biology, history, civics, Hindi, English, any subject you give the examination, whenever a question is there, go through stepwise on each part of the question, and the way you answer will pop up immediately. How it is so? See, go through each and every part of the question. What's this? The line drawn through the center of a circle. Got it? What I have to do first, I have to make a circle. A line drawn through the center of the circle. Center of the circle. Circle is made, one thing is finished. One requirement of a circle is finished. Through the center of the circle, center is made O. Center is made. To bisect a chord, now make a chord A and B. Give it a name. A line drawn, a line is drawn to the center of the circle to bisect. A bisect means this side is equal to this side. Bisect a chord is perpendicular to the chord. We have to prove that this is perpendicular. Whatever this line or this theorem or this question is saying, you have to keep your eyes on stepwise. Don't take the whole question at once. divide it into pieces and define, and you will make a clear diagram. If you will not do so, you will be in trouble. Don't forget, you have not to take the question as a whole at a time. Instead of that, you have to divide it in fragments or segments and then define it on a paper like a structure and then solve it. Many things will be clear and your diagram will never be wrong. Once your diagram is not wrong, your answer will be correct. So, according to the question or the theorem, I have made this diagram and gave it a name. One point is missing by putting a name over there, and this is the center point where this line is touching the chord that I am giving M for convenience. I don't know whether this is 90 degree or this is 90 degree, but it is saying it is bisecting it. Now, what you have to do immediately, you see, this cannot hang on like this in an open space of a closed circular path. But what we have to do, immediately you touch these 2 points. As soon as you touched both these points together, you have seen there are 2 triangles in a triangle. Okay? Now start defining it. Whatever it is saying, you have to write it. OA. Now, in triangle, what you will write? A in triangle OAM and triangle OBM. You have to write this line, which is very much important, because where you are going to put your ideas and theorems. We are going to put our ideas and theorems in this closed area, which are closed in a form of 2 triangles. So you have to mention, don't forget to mention where you are going to apply your theorem or your knowledge. So I have mentioned this is the area of our consideration. This is an area. So taking together both the triangles, we will define afterward. What's that? OA is equal to OB. OA, this is equal to OB. Why it is so? Because these are radiuses, and radiuses are always equidistant from the circle. Therefore, circles are formed. So this side is equal to this side. You have to write it in bracket. It is radius. 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 First thing you have mentioned. Now, AM is equal to MB. Or if I am using the M in the second point, then I again have to use the M in the second point. It was OA, OA, OB. From here to here, then also from here to here. Not from here to here. You cannot write BO. Although it will be correct, but your presentation for getting 100% marks will be wrong. So OA, O in the beginning, is equal to OB. These are laws of triangles. Now, what you will write? AM is equal to BM. From here to here, again from here to here. BM. Not AM is equal to MB, although it is correct. Why it is so? Theorem says bisect a chord. Bisect means 2 equal parts. What then? These are same. Bisect. Bisector. Equal halves. AM is equal to BM. Now, in this triangle, I have mentioned here, I am putting it in bracket for the sake of easiness. I have given 2 different triangles, OAM and OBM. OAM, this triangle, OBM, this triangle. Now in both these triangles, this OM is common. For this triangle, this is OM. For this triangle, this is OM. So for this triangle and for this triangle, OM is common. So how we will define it? We will define it for both the triangles. It's a part of this and a part of this means it's a common boundary of both the triangles. Hence, we will define it like this. OM is equal to OM in bracket, you will define COMMON, common. So this is common. Got it? Similarly, if this side is equal to this side is equal to this side, so this side is equal to this side, it means side property, this triangle is congruent to this triangle. So how we will write it? Congruent means similar, accurately similar, means it is overlapping on this hand. This palm is congruent to this palm, this is overlapping with each other. Each and every part of the palm physically are same. So this triangle OAM, so triangle OAM is equal to triangle OBM. Okay, but these are congruent, not equal. So what does it mean? If these are congruent, then make S-like structure on top of it. This is a symbol of congruency. Yeah. Oh my God. They are shining. Now, up.
अब ऊपर जहाँ पे एंगल OBM है वहाँ पे चमक रहा है.
No way. What can I do for that? It is very much difficult that it is shining, but you have to understand. Okay, zoom it and watch it. So this triangle is congruent to this triangle. They both are congruent because of side property. So you have to define here as property. If they are same, it means this angle is equal to this angle. What it shows, rest of the things we will not define, although you have to know it means this triangle is congruent to this triangle. SSS property is shown that all the sides are same. It means if the triangles are congruent, its angles are also same. Its angles are also same. So this angle is equal to this angle. This angle is equal to this angle. And this angle is equal to this angle. But we don't know this angle is equal to this angle, this is equal to this is equal to this, because this is a congruency. If this is congruent by the arms, this is congruent by the angles also. Angles are also same. But similar angles means A is equal to B, AOM is equal to BOM, OMA is equal to OMB. Now, how you will say that this is 90 degree, although you have come to know that this is equal, this angle is equal to this angle, it is 90 degree, but how you will write it? OMB is equal to angle, right? Angle OMA is equal to angle OMB by congruency. Okay, by congruency. OMA is equal to OMB. If this angle is equal to X, this also would be equal to X. Hence, X is equal to X degree, or angle x is equal to angle x because they both are same. If this is x, then this is also x. Now, up what you will write? Angle AMB is equal to 180 degree. Why? Straight line. This is the most important part to prove that this is 90 degree. The most important part, which is missing in most of the textbooks and most of the books. This part is missing. So, what's that? A and B is equal to 180 degree. And what is this A and B? A and B is equal to sum of the AMO plus BMO. Means angle AMO plus angle BMO is equal to 180 degree. It is given as x degree plus x degree is equal to 180 degree. So 2x degree is equal to 180 degree. It means x is equal to 90 degree. If x is equal to 90 degree, this is 90 degree. So the line drawn through the center of the circle to bisect a chord is perpendicular to the chord. Now you have proved that OMB is 90 degree and OMA is also 90 degree. So OM is perpendicular on AMB. So OM, line OM is perpendicular, make a symbol of perpendicular on chord AMB. This is the line, the final answer. OM is perpendicular on the chord AMB. So you write it down because this is not, these lines are nowhere in any book. Got it? And these are the most important lines. What they will say? By this, we prove this. So this is 90, this is 90. They will say like this. They will shorten or minimize. They think that you already understood. But you have to draft clearly or you have to mention it clearly in your examination. So my dear friends, dear students, hope you would have learned it very carefully. And now I am going to clear it out. Now what happens? Hope you will understand. Now the second part, which is the most important part again in the circle chapter. After this circle chapter, tomorrow I will teach you coordinate geometry. Actually, I just want to teach you all those new topics which are added this year in your mathematics subject, because I don't know which type of the teacher you will get and how they will be able to teach you and how much seriously they will take your future and how much seriously they will indulge in their topic. So I am going to teach you all those topics which are newly added this year in class 9th, and they are very much important for you to know, because all the topics which are very much old and you are learning constantly from class 3rd onward, and you understand those topics pretty well. So these are absolutely new topics like trigonometry, circle, and tomorrow I will teach you the coordinate geometry, which is very much important and it helps you throughout your life. So you be prepared for that. And it is not possible, I think it is not possible for you to learn it from the very beginning before I teach you, because the books are not available this time and you don't know which type of the books you have to study. And I just want to show you one thing.
ये है एक बार मैंने लिखा ही है
कहाँ है?
आरटी शर्मा
And I am having this much bunch of the books, and this is the mathematics of Das Gupta, A. Das Gupta, and Banerjee. This is one mathematics books for class ninth. This is the second mathematics book for class 9, concise mathematics, and it is written the Salina publication. This is S. Chan publication, ICSE mathematics class 9th, third book. This is fourth book, Understanding ISC Mathematics class 9th by M.L. Agarwal. This is the fourth book. And likewise, I am having the fifth book, which is R.D. Sharma, the most important books. So I am giving all these lectures according to the 5-6 books, and hope it is not easy part for you to study all the books simultaneously. And this is R.S. Agarwal book. And likewise, I am having 5 mathematics books, and I am taking the reference of all those books for make your topic simpler and easy to understand. And so it is very much important for you to take my all classes very regularly and seriously, because every subject I am teaching you here is just a reference from not only from one book or two books, but I am having a lot of books. I take all those books under consideration when I take any lecture. So the next part of the circle is now the circle through 3 points. Now, if this is a point, it do not have a particular value of understanding this point, because in physics I told you a point is a reference point only. It do not have the x-axis or y-axis or z-axis, so it is non-directional or it is a scalar quantity. From now, see in mathematics how it proves that it is not directional. See, you can draw a circle through this point like this, through this point like this, through this point like this, and through this point like this. You can make any circles, as many as you want, through this point. Not a particular. It is not a confined. Means at any part of through this point you can make a circle. Got it? But if this point is 2 in number, 1 and 2, 1 point and second point, then how many circles you can draw? Your circles will be restricted now. Here the circles were not restricted. Any direction you can take those circles. Any direction, because this was only 1 point. But if this is 2 points, then your circle would be like this, or like this, or like this. A smaller circle or bigger circle or more bigger circle. Now your circles are in a particular axis. You can make your circles either up or either down. You can make your circles either up or down. It is not possible for you to make your circle including both the points in this way. If you will make a circle like this point will not be included. Including both the points or taking both the points under consideration, you can draw a circle only in one axis. But what happens when we consider 3 points? What happens? Then you see, at that particular situation, this is the important point, and this is a theorem also. The way I am telling you is a 1 point, 2 point, and 3 point. It is not for defining anything for the future. This is a theorem, and this theorem will provide you 4 numbers or 5 numbers. If there are 3 points, 1 point, 2 point, and 3 point. Can you draw a circle through these 3 points? Absolutely not. Because either you will make a circle like this, or a circle like this, or circle like this, but including all these 3 points like this, you cannot make a circle. 2 circles will be. So at this condition, this happens. This happens only these points are collinear, means in one line. If these 3 points resides on a line, means all these 3 points A, B, and C are collinear. At that particular point, you cannot draw any circle. But as soon as this property of collinearity disturbs, you can make a circle, only one circle. When it was one point, you were capable to make many circles or infinite circles through that single point. But when the points were two, you were capable of making many circles, but only in one axis. But if the points are three, except collinear points, then you are capable to draw only one and one circle. How it is so? It is so like this. If this is non-collinear point, these are collinear points, so you cannot draw any circle including all 3 points together. So you have to take three different points, but they should not be collinear. It means if one point is here, one point is here, and one point is here. This is the point number A, this is the point B, this is the point C. Now, these are 3 points which are non-collinear. So you draw or just join them together, A to B and B to C. Take a protector or compass, anything you take, just bisect this line or this chord. I will use the word chord here, okay? Chord means the line. Because this is a circle chapter, so in here, if line will be there, so I cannot compare that line with the circle. But if I will use the word chord, it means circle is there. So I will bisect this. How you bisect a chord? Or how you bisect a straight line? Take your compass, any length, and just make one cross here, at the same distance, one here, here, and here. Join it together and bisect this line. Do the same for this. Take this point, one cross here, one cross here, one cross here, one cross here. Join it together. Wherever these border lines are touching, these hypothetical lines, by bisecting AB and BC, where they are touching, make this a center and put your protector of compass here and just draw a circle. So what this happens? This is a circle with the center O. So non-collinear 3 points makes only one circle. So this is also a theorem, and sometimes in geometry you get 5 marks to prove this. Just join these points AB and BC, bisect these points at the point O, and bisect this point, and this line is bisected, or this chord is bisected, this chord is bisected, where they both bisectors are meeting up. Make that a center, and by it make a circle including all these 3 points. You will get exactly the 3 points are making only single circle. It means 3 non-collinear points are capable to draw up a circle. This is an important part, and this is an important theorem also. But if the points lie on a line, then the third point will lie inside or outside the circle passing through the points if they are collinear. Sometimes teacher may confuse you. If the points are collinear, at that time either one point will reside outside the circle, means exterior point, it will become an exterior point. Or if you will draw a circle like this, the one point becomes interior point. Teacher may ask this question to you orally, but at that time your geniosity will come out like this, that when you draw a circle by three collinear points, only 2 points will be used to making a circle, either this or this, or either this or this. If these 2 points were used, then this point, the third point, will be an external point. And if these 2 points, external and internal, both extreme points were used for to drawing a circle, then this point is the internal point. So it is never possible to draw a circle through three straight collinear points. Now, I have drawn this and cleared a theorem. One important part, one more theorem, which is also important. There is one and only one circle passing through these three non-collinear points. And what is that theorem? That theorem is there is only one there is only one circle passing through, only one circle passing through, there is only one circle passing through three given non-collinear points. Three given non-collinear points. There is one and only one. There is one and only one circle passing through three given non-collinear points. This is a theorem, and that theorem is defined over here. Now, if ABC is a triangle, then the theorem this is unique circle passing through these three vertices. How these three vertices are A, B, and C. Vertex means the topmost part. Vertex of a triangle means this is the vertex. For this is a vertex. This is a vertex. Depends what is the base for you. Given an arc of the circle, if an arc of the circle is given, that time too you can complete a circle by this one. Now, equal chords and the equal distances from the center. This is the final part of the circle chapter. Why this is final? After this, the chapter will be finished, and this much is given for the class 9th introduction for the circle. As circle is one of the most important part for your board examination, it is so much interesting that you can solve thousands of the questions about circle quickly on tips. Even you don't need to use your pen. In air, you can solve it if your theorems and your concepts are clear. You don't need to pick up a pen and draw it on paper, because your concept should be 100% clear. Now, equal chords and their distances from the center. This is a topic. Equal chords and their distances from the center. Distances from the center. If a circle is drawn, then two types of the diagrams can easily be seen. One is, this is a circle, this is its center O, this is a chord, and this is a chord over here. These two chords are equal. Equal chords, equal should be underlined. This chord AB is equal to chord CD. Got it? And through this you can make a diameter. Now, Draw a perpendicular through the center O. This is 90 degree. This is 90 degree. This is 90 degree and this is 90 degree. Now you have seen that two equal chords which are equal distances, because if the chords are equal, then its distances from the center will also be equal. Yesterday we have gone through that. Now what happens? Two equal chords and their distances from the center. How you will prove it? That distances are equal. Means O and O and are equal. One diagram is this. Other diagram. This is center. These are two equal chords. Join it to the center. A, B, C, D, M, and N, O. These are two equal chords. This time they are not opposite to each other. They are somewhat in the same way. Equal chords. So equal chord can be drawn like this also. One more circle. This is a center O. This is a chord and this is a chord. A, B, C, D. Center O, perpendicular, perpendicular, M, and N. These are also two equal chords. And any type of the diagrams can be seen in the examination. In this type of the diagram, the person who is making the question can confuse you by saying the distance between these two chords is 10 centimeter. Distance between these two chords is 10 centimeter. If the chords are equal, it means this will be 5 centimeter and this will be 5 centimeter. If chords are unequal and distance is 10 centimeter, it means one distance will be x from O and other will be 10 minus x. So if you will make a formula or an equation, then both the equations will be formed according to a common alphabet x, and it will be easier for you to solve for x to find out whether this is 3, 4, 5, 6, 7, 8, 9 or 1, whatever it is. Got it? If the distance between these two is given and the chords are equal, then the distance will be equal. But if the length of the chords are not equal, at that time distance is given, then you have to immediately take one as x and other 10 minus x. So you can easily solve those type of the questions. That time your creativity will be proven. So many questions are there too. In the future you will meet out all those questions. But here our concern is the equal chords and their distances from the center. So you have seen these three type of the example I have given over here. Now you keep it in your mind. I am now going to solve it in a way you have to know what the theorem is going to be used in this form. I am going to rub it out. Hope you have tapped into your brain. I will finish this chapter today. Now, what happens? Theorem is equal chords of a circle, okay, are equidistant from the center. Equal chords of a circle, of one circle, okay? Equal chords of a circle, you can say one circle, Got it? Are equidistant from the center. Are equidistant from the center. Equal chords of a circle are equidistant from the center. And this is a theorem. You have to prove this theorem according to your requirement. How you will prove it? Now, the chords equidistant from the center of the, or this theorem can also be chord equidistant from the center of a circle are equal in length. Or chords equidistant from its center are equal. Means if this is a circle, these are equidistant, equal chords AD and CD. This is the center O. If this is equidistant, means this side is equal to this side, then chords are equal. Then chords are equal. If the chords are equal, they are equidistant by both sides. If the chords are equal, distance is equal. If distances are equal, it means chords are equal. This is a theorem. Got it? So how you will prove it? Now the proof, which is going now here. And this is the last part of this chapter. And after this will be finished. But don't forget the concepts I am telling you and going to tell you here. These concepts are very much important. It will increase your mental capacity, your style of thinking, and the way you take a question. So be careful, take it seriously, concentrate only on the board. It doesn't matter whether it is looking clear or not. Clarity of the transmission depends on many factors, not only one factor that my camera is perfect or not. I am using laptop to define it out. So what happens here, students? I am going to make a circle. I am going to make a circle. What's that? Here I am making, and here I will solve it out. Diagram may be slightly confusing, but you watch it carefully, so it will no longer be a confused diagram for you. Got it? This is a circle. This is one chord. This is another chord. This is a center O. Now, draw a perpendicular on this chord. Draw a perpendicular on this chord. Give it a name. A, B. One chord. C, D. Another chord. Now draw a diameter. Diameter will pass through the center O. So this is a diameter. Name it P and Q. Center as it is O. M is the center point where this is touching, and L it is touching. This is a point where it is touching this one, A, B, C, D, E or F. Anything you can take. So I am going to take E here. Now, how many angles you are watching here? 90 degree, 90 degree, this angle, this angle. Okay. Now what happens? In take the triangle. Which triangle you will consider first? We will take this as a triangle and this as a triangle. Means OLE and OME. OL in triangle, OLE and triangle OME. Sum of the triangles is 180 degree. Means OLE, angle OLE plus angle LEO plus angle EOL 180 degrees. Sum of all these angles is equal to 180 degrees. Or for understanding it in the better form, you can say X degree, Y degree, Z degree. Means X plus Y plus Z is equal to 180 degrees. Then exterior angle is equal to sum of the interior opposite angles. Means X plus Y is equal to 90 degree. Got it? Means angle Y. So take angle Y is equal to 180 degree minus Z minus X. And Z angle, as this is the perpendicular on this, so angle Z is equal to 90 degree. So this will be 180 degree minus 90 degree minus X, means 90 degree minus X is equal to Y. So Y is equal to 90 degree minus X is equal to this. Got it? 90 degree is equal to this. Now what happens? 90 degree minus this angle LEO means X is equal to angle AEQ. You can write it down. Got it? This X is not only for LEO but also for AEQ. You can better write it like this: angle AEQ, angle this is equal to angle this is equal to angle LEO. They both are same because they are common. You can write it here common, COMMON. Got it? So like this, LEO and NEO are you understanding what I am saying? In the triangle OLE and OME, we have what seen? This angle is equal to this angle. If the two intersecting chords of a circle makes equal angles with the diameter passing through their point of intersection, if the chords are crossing each other, diameter passes through it, that divides it into equal parts. It means if this is X, this is also X degree. Hence, this angle is equal to this angle. AEQ or LEQ, angle LEQ is equal to angle NEO. LEO, sorry, MEO. They both are same because diameter is bisecting both these angles. Why it is bisecting? Because these are common chords, two different chords. If two intersecting chords of a circle makes equal angles with the diameter passing through the point of the intersection, then the chords are equal. This is also a part of this. It means if it is this, both angles are same and this is 90 degree, it means this is y, then this is also y. Angle, if this is so, then angle LOE is equal to angle MOE. Proved. Because diameter bisect. Diameter bisects. The sum of the triangle. This is 90 degree and this is 90 degree. But not yet. This is proof that these both the chords are equal. Now only angles are equal. Angles have been proved are equal. It means this triangle is congruent to this triangle. And triangle OLE congruent to triangle OME. Only congruency has been proved till now. It means OL is equal to OM. CPCT. Congruent part of congruent triangle. This is the triangles are congruent. What is its congruent part? This is 90, this is 90. It means this is equal to this. If they both are same, it means the chord this is equal to chord this. In the CPCT, OL is equal to OM. Yeah, perpendicular OL is equal to perpendicular OM. It means when the perpendiculars are equal, the chords are equal. This is a theorem. It means AB is equal to chord AB is equal to CD theorem. Like this, you can prove that this chord is equal to this chord. Sometimes there is a different method also. This is the method given in most of the books, and a teacher teaches you like this too. But there is also a simpler method. I will wash it out and I will teach you that simple method, which is very much simple, and you will understand it very clearly. I am washing it out. Okay, now see how easy it is. And you will love it. It's a fun. This much complicated theorem, this much complicated proving can be so much easy. Okay. Now what's that? Join this by this, join this by this, join this by this, join this by this. Now take triangle OCD. In triangle OCD and triangle OAB. OA, simple. This side is equal to this side because these are radius. This side is equal to this side, radius. It means this is an isosceles triangle. So this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. We don't know which angle are these, but these angles are same. If these angles are same, this is equal to 90 degree minus 2x, 90 degree minus 2x, and this is 90 degree minus 2y. Got it? Now divide it into two pieces as you divided earlier 2. This is 90 degree. This side is equal to this side. This is 90 degree. This is a different angle, and this is equal to, now the two angles, they are having the 90 degree. This is y degree, now minus 90 degree. This is y minus 90 degree, or 90 degree minus y degree. Now what you will see, the diameter is bisecting it into pieces. If diameter is bisecting it, then take this triangle under consideration and this triangle under consideration. It means this angle is equal to same, this angle is equal to same, and this is a common part, and this side is equal to this side because they are diameters. At that time, and this side is equal to this side, this is the common, and this is one angle is equal to this angle, side angle side property, this triangle is equal to this triangle, and this side is equal to this side too. And if this side is equal to this side, it means the remaining side are there. Means AE is equal to DE. By this kite-like structure you have seen. AE is equal to DE is true. And by joining these two lines, again a kite-like structure is being formed. This is dividing it into two pieces. This angle is equal to this angle, and this side is equal to this side radius. This is common. The side angle side property. This triangle is common to this triangle, so this is equal to this. This is equal to this. Means how I did, I am dividing it into two pieces like this. One chord, another chord. This is center line. This is with the center O. This is with the center O. Now, see, first I am taking this triangle and this triangle. Radius. This bisect the angle. If these two arms are equal, it means this angle is equal to this angle x. Side is equal to side. Angle is equal to angle. Common. So side is equal to side. Means side angle side property. This triangle congruent to this triangle means this side is equal to this side. First part you have proved it. In the second part, I am coming up here. What is that? Again, I am making this diagram being divided by these two. So it will divide it into two pieces. This side, this angle is equal to this angle. Got it? Now this is dividing it into two pieces. This angle why should I use this one? Why should I go this much hard? I am seeing one more easy way, one more easy pattern here. What's that? Rather than making this triangle, I will make this, join this. What happens? This is dividing. This is the radius. This side is equal to this side. This line divides this into two equal half, y degree to y degree. This is common in this triangle. In this triangle, this is common. This side is equal to this side radius. This angle is equal to this angle. Side angle side property. This triangle congruent to this triangle means this side is equal to this. Now, by this triangle, like kite, you prove this side is equal to this side, and now this side is equal to this side means this plus this is equal to this plus this. How? This was A. This was B. This is C. This is D. This is E. Suppose. Now AE is equal to ED. We proved AE is equal to ED. We proved equation number 1. And BE is equal to CE. We proved BE is equal to CE. We proved equation number 2. Adding both these equations, you got AE plus BE is equal to ED plus CE. AE plus BE AE plus BE is equal to AB. ED, ED plus CE is equal to CD. Rule PROVED. This plus this is equal to this, and this plus this is equal to this, as these were all equal, so AB is equal to AB. Like this, you have seen the chapter is finished, and this much complicated cheat which is given in your textbook is this much simple. Only what you have to do, you have to segment it into two diagrams. This is the center part passing through O. One diagram was formed like this. This was the curve. So first you will take under consideration this, because diameter is bisecting into two pieces. This is the angle, this is the radius, and this is common side angle side property. This triangle congruent to this triangle, so this side is equal to this side. AE is equal to ED. Now join this like this. Again, this line is bisecting these two angles. This is x degree, this is x degree. These are radius common, and this is a common part because this is a part of both the triangles. Hence, this triangle is congruent to this triangle. Now, this triangle is taking place. So, this side is equal to this side. So, this side is equal to this side means D is equal to C. Adding both the equations, you got AB is equal to CD. Solved, and it is this much easy. Now, today's lecture is finished. Oh, and now you practice this chapter, circle, and tomorrow I will teach you coordinate geometry. So be ready for that. A very important part. Like this, I will finish in mathematics, trigonometry, circle, and coordinate geometry. Isn't it good? In these holidays, you are preparing very nicely. And in physics, I have finished two chapters, motion in one dimension, and graphs, two chapters. In chemistry, I have finished at least one chapter, almost one portion of a chapter. In biology, half chapter I have finished. Very sooner or later, I will finish it too. Okay. Oh, I am fully tired. It's so boring to teach here. Anyway, it's my duty. So I think it's going to rain outside today. So enjoy the raining. Tomorrow we will meet if my connection and light will intact. Thank you so much. Bye.